For fluorescent lights, 14 American wire gauge is the standard and most commonly used wire size. It is sufficient for most applications and meets all code requirements. 12 American wire gauge is sometimes used when there are high current loads or extended wire runs, especially in commercial and industrial settings. However, unless specifically required by the fixture or calculation, 14 American wire gauge is generally adequate. In general, it is not necessary to use 12 American wire gauge for fluorescent lights in residential or small commercial applications. 14 American wire gauge is suitable for the majority of installations. However, it is always important to consult local codes and perform proper load calculations to ensure compliance and safety. When choosing the appropriate wire gauge for electrical circuits, several factors must be considered to ensure safety and compliance with the electrical codes. The most common factors include ampacity, voltage drop, and the specific requirements of the connected load. Firstly, ampacity refers to the current carrying capacity of a wire. It is the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The National Electrical Code, or NEC, provides tables that specify the ampacity of different wire gauges based on their insulation type and operating environment. For example, Table 310.15. B16 in the NEC lists the ampacities of conductors based on insulation type and temperature rating. Secondly, voltage drop is a reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, operate inefficiently, or overheat. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law and considering the wire's resistance per unit length, which is typically found in wire manufacturer data. Thirdly, the specific requirements of the connected load, such as fluorescent lights, must be taken into account. These requirements may include the minimum wire gauge specified by the equipment manufacturer or any special considerations for the type of load. For fluorescent lights, the standard wire size is typically 14 American wire gauge, which is generally sufficient for most residential and small commercial applications. However, 12 American wire gauge may be used when there are high current loads, extended wire runs, or specific requirements of the lighting fixtures. To determine the appropriate wire gauge, perform a load calculation that takes into account the total current drawn by the fluorescent lights and any other loads on the circuit. Also, consider the length of the wire run and the desired voltage drop. If the load calculation indicates that 14 American wire gauge is sufficient and the voltage drop is within acceptable limits, then 14 American wire gauge can be used. If the load calculation indicates that 14 American wire gauge is not sufficient or the voltage drop is excessive, then 12 American wire gauge or a larger wire gauge may be necessary. In addition to these factors, it is important to consult local electrical codes and regulations which may have specific requirements for wire gauge and installation practices. Always follow these codes and regulations to ensure compliance and safety. Also, consider the type of insulation on the wire. Common types include THHN, THWN, and ERF. Each has different temperature ratings and suitability for wet or dry locations. Ensure the chosen insulation is appropriate for the installation environment. When dealing with fluorescent lights, consider the ballast type. Electronic ballasts are more energy efficient and may have different wiring requirements compared to magnetic ballasts. Refer to the ballast manufacturer's specifications. For long wire runs, consider using a larger wire gauge to minimize voltage drop. This ensures the lights receive adequate voltage for proper operation. In commercial and industrial settings, it is more common to use 12 American wire gauge for fluorescent lighting circuits, especially for long runs or when high current loads are anticipated. In residential settings, 14 American wire gauge is typically sufficient for most fluorescent lighting circuits. Always check the fixture's requirements and local codes to ensure compliance. If you are unsure about the correct wire gauge to use, consult a qualified electrician. They can perform the necessary calculations and provide guidance based on your specific situation. Always turn off the power to the circuit before working on any electrical wiring. Use appropriate safety equipment, such as insulated tools and gloves. When connecting wires, use proper wiring techniques and connectors to ensure secure and reliable connections. Avoid overloading circuits, as this can lead to overheating and potential fire hazards. Distribute the load evenly across multiple circuits if necessary. When installing wiring, follow best practices for routing and securing the wires to prevent damage or strain. Label circuits clearly to avoid confusion during maintenance or repairs. Consider future expansion when planning electrical circuits. It may be wise to use a larger wire gauge than currently required to accommodate future loads. Regularly inspect electrical wiring and components for signs of damage or wear. Replace any damaged or worn components promptly. Keep electrical panels and equipment accessible and free from obstructions. This allows for easy maintenance and repairs. If you notice any unusual electrical problems, such as flickering lights or burning smells, investigate the issue promptly. Contact a qualified electrician if you are unable to resolve the problem yourself. Grounding is an important safety measure in electrical systems. Ensure that all circuits and equipment are properly grounded to prevent electrical shock hazards. Use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of water exposure, such as bathrooms and kitchens. GFCIs can detect ground faults and quickly shut off the power to prevent electrical shock. When working with electrical wiring, always follow lockout-tagout procedures to prevent accidental energization of the circuit. This involves disconnecting the power source and placing a lock and tag on the disconnect switch to indicate that the circuit is being worked on. Use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. Surge protectors can help prevent damage to equipment and data loss. Consider using energy-efficient lighting fixtures and appliances to reduce energy consumption and save money on utility bills. Energy-efficient products can also help reduce the strain on electrical systems. When replacing wiring, use the same type and gauge of wire as the original wiring. This helps ensure compatibility and safety. If you are unsure about the type or gauge of wire to use, consult a qualified electrician. When installing wiring in walls or ceilings, use appropriate wiring methods such as conduit or cable trays to protect the wiring from damage. Follow the NEC guidelines for wiring methods and installation practices. When working with electrical wiring, always use the proper tools and equipment. Using the wrong tools can damage the wiring or create a safety hazard. Before starting any electrical work, obtain the necessary permits and inspections from your local building department. This helps ensure that the work is done safely and in compliance with local codes. Regularly test smoke detectors and carbon monoxide detectors to ensure that they are working properly. These detectors can help alert you to potential fire or carbon monoxide hazards. Keep flammable materials away from electrical panels and equipment. This helps prevent fires and explosions. If you smell gas, evacuate the building immediately and call the gas company or fire department. Gas leaks can be extremely dangerous and can cause explosions or carbon monoxide poisoning. Educate yourself and others about electrical safety. Knowing the basics of electrical safety can help prevent accidents and injuries. Always be cautious when working with electricity and follow all safety guidelines. Electricity can be dangerous, so it is important to take it seriously. The American wire gauge, or OG, system is a standardized wire gauge system used predominantly in North America for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the AWG number, the smaller the physical diameter of the wire. This can sometimes be counterintuitive, as a higher number indicates a smaller wire. The AWG system is based on the number of dies required to draw the wire to the desired size. Very thick wire, designated with gauges 0, 0, 0, and 0, is often referred to using multiple zeros. For example, 0 is often read as double aught. For sizes smaller than 40 American wire gauge, other standards are used. The diameter of a wire is an important factor in determining its current carrying capacity, or ampacity. Thicker wires have lower resistance and can therefore carry more current without overheating. The ampacity of a wire is also affected by the type of insulation used and the ambient temperature. The National Electrical Code, or NEC, provides tables that list the ampacity of different wire gauges based on these factors. When choosing a wire gauge for a particular application, it is important to consider both the ampacity of the wire and the voltage drop that will occur over the length of the wire run. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law and the wire's resistance per unit length. In addition to ampacity and voltage drop, other factors to consider when choosing a wire gauge include the type of load, the operating environment, and any local codes or regulations. For example, certain types of loads, such as motors, may require larger wire gauges to handle the inrush current that occurs when the motor starts. The operating environment can also affect the choice of wire gauge. For example, wires that are exposed to high temperatures or corrosive chemicals may require special insulation or larger wire gauges to prevent damage. Local codes and regulations may also specify minimum wire gauges for certain applications. It is important to consult these codes and regulations before choosing a wire gauge. When installing electrical wiring, it is important to follow all safety precautions to prevent electrical shock or fire. Always turn off the power to the circuit before working on any wiring. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. When connecting wires, use proper wiring techniques and connectors to ensure secure and reliable connections. Avoid overloading circuits, as this can lead to overheating and potential fire hazards. If you are unsure about any aspect of electrical wiring, consult a qualified electrician. They can provide guidance and ensure that the wiring is installed safely and in compliance with all applicable codes and regulations. Regarding grounding, a grounding conductor provides a low impedance path for fault current to return to the source. This helps to quickly trip the circuit breaker or fuse, preventing a dangerous voltage from being present on the equipment. The size of the grounding conductor is typically based on the size of the ungrounded conductors in the circuit. The NEC provides tables that specify the minimum size of grounding conductors for different circuit sizes. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and quickly shut off the power to prevent electrical shock. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Surge protection devices, or SPDs, protect electrical equipment from voltage spikes and surges. SPD are typically installed at the service entrance to the building and at individual electrical panels. SPD can help prevent damage to equipment and data loss caused by voltage surges. Electrical systems should be inspected regularly to identify any potential problems. Inspections should be performed by qualified electricians and should include checking for loose connections, damaged wiring, and overloaded circuits. Any problems identified during the inspection should be repaired promptly to prevent electrical hazards. The proper selection and installation of wire gauges is a critical aspect of electrical safety. By following the guidelines provided in the NEC and consulting with qualified electricians, you can ensure that your electrical system is safe and reliable. Always remember to prioritize safety when working with electricity. Electricity can be dangerous, but by following proper procedures and taking precautions, you can minimize the risk of electrical shock or fire.